And number 7, we're given a vertical position graph. And it says the vertical position of the elevator as a function of time is shown above. On the grid below, velocity time graph, we're supposed to graph the velocity as a function of time. Well, velocity is given as the slope of the position time graph. And the slope from 0 to 8 seconds is constant. So it's 12 divided by 8, and that's 1.5. So for the first 8 seconds, it's a constant 1.5. And then it's also constant from 10 to 18 seconds. The slope is 0. So we just simply need to connect the two here between 8 and 10. And constant acceleration. And there's a constant slope here from 20 to 25 seconds. And so that would be a rise of negative 12 over 5. And that gives you so negative 2.4. Negative 2.4 would be right about here. That's at 20 seconds. That's all the way to 25. So that's the constant. Well, and then I have to connect these two. Okay, then calculate the magnitude of the average acceleration between 8 and 10 seconds. Acceleration is defined as the change in velocity over change in time for this time interval here. So the change in velocity goes from 1.5 to 0, and so it's going to be 0 minus 1.5 meters per second divided by time of 2 seconds. And so we get an acceleration of negative 0.75 meters per second squared. It just wants the magnitude though. So the magnitude is positive 0.75 meters per second each second. Part 2 says on the box below that represents the elevator, draw a vector that represents the direction of the average acceleration from part 1. Well, this thing is moving upward, but the acceleration is downward. It's slowing down. See, that's slowing down here. So that means the acceleration is that way. And then finally it says, suppose there is a passenger of mass 70 kilograms in the elevator. Calculate the apparent weight of the passenger at 4 seconds. So at 4 seconds, we are right here. Constant velocity, that means there's no change in motion. So if you're thinking about the free body diagram, we have a support force up, we have a weight force down. Those two are equal. The person doesn't really feel their weight, they feel the support force, but it happens to be equal to the weight. So the apparent weight is the support force. If there's 70 kilograms, the weight would be then 700 newtons.